G'day everyone, how are you going? Another video back here in methods for the start of term 3. It's the power term. It's the one where you just want to treat it like a sprint. It really must be a race to the end, but have a little bit of time for yourself along the way as well. Make sure you have time to smell the roses. What are we doing today? We're differentiating natural log functions. So we've done a bit of work around natural logs and we're pretty good with it. We can rearrange, we can manipulate, we can solve, we can do all of that. We need to look at differentiating these sort of functions. Now, differentiating natural log of x, see it like this. It's log base e. And if you remember, when we did logs and we did base e, e is that fantastic number, 2.718, where the slope of the graph is equal to the value of the graph for any x value. Think about that. So usually when you have the gradient or the slope of a graph, it is not necessarily the same as the value of the graph or where it is on the y-axis. But with e to the x, the value of the gradient is equal to the value of the function. Okay? Important point to remember. Look back on a previous video if you need to. What are we doing? Well, straight away you can see I've rearranged this one into index form. That's my first step. Get rid of the log. Get it out of the way. I don't want to deal with that at the moment. Now I'm here. What I'm going to do is just write this the other way. X equals e to the y. Nothing fancy there. But here's the trick. The trick is thinking, do I need to start with dy dx? And the answer is no. That's where I want to finish. Dy dx, derivative of y with respect to x. But this is looking a bit crazy here. I'm not sure I'm going to be able to do anything with that. So if I rearrange here, and now if I take the derivative of d dy. Now this might be new notation to you. We did a little bit of work in spec around implicit differentiation, needing this notation. That's really what we're doing when we're doing a derivative, is to say, take the derivative of this thing with respect to y, or some variable. And in the same way, I've got to put one in here as well, because I've got to do the same to the left and the same to the right. Adding 5, taking 5, multiplying by 5, whatever it is I'm doing, same to both. Now what I end up with there is dx dy, jumping ahead already. I end up with dx dy there. Okay, and that's what I'm thinking that's a step on the way. Here, I need to take the derivative with respect to y of e to the y. Now, those that are kind of thinking ahead, you will remember if I had, look at this for a minute, y equals e to the x, and I took the derivative of it, y dash or dy dx or f dash of x, then the rule is power out front, derivative of out front, and write the same again. So this would be that there, wouldn't it? Right? So dy dx here would be that. Well, if dy dx here ends up that, why can't I do d dy, that's the derivative with respect to y, use the same idea here, but wouldn't this really be power out the front and the derivative of 1 times e to the y? That I'm using the same idea, it's exactly the same concept. Now I look at this and I think, I'm not really there yet, it's not really what I want, because I really want dy dx, not dx dy. But with any limits, we can just take it and flip it upside down. So this becomes dy dx equals, well the one I don't need to worry about, 1 times it's just itself, e to the y becomes 1 over e to the y. So now it seems like I've got what I want, dy dx, but because it is dy dx, the rate of change of y with respect to x, ideally over here, I should only have x's involved, not y's, because it's with respect to x. So then I just look over here and I say, well actually, I know e to the y equals x. So I can just write dy dx equals 1 over x. And now I have dy dx of my original function. So if I need to differentiate y equals natural log of x, the answer is 1 over x. Now that's okay in a simplistic case. We've got to be a little careful. Don't think that always this works. What you have to think here is that I started with the simplest case that I could just here, just x, right? I didn't start with 3x squared, I didn't start with 2x squared over something else or whatever. I started with the simple to get the simple out. But let's just expand that a little bit. What I need to recognize is that if I have y equals log base e of f of x, a function of x in there, right? Then dy dx is going to be equal to, now think, that became that. So isn't the derivative of that one? So on my top line it's f dash of x over, and that one just appeared on the bottom, f of x. So that there is the rule I need to work to. But of course, in showing you how it works, I want to start with a simple case. It'll get too complex otherwise. So this is the rule you want to work with. Now the next thing that we will do, and I might not even do a video on this because I don't think we need to, is that if you see a function like this, the derivative is on the top line and the original on the bottom. So it could be 3x squared over x cubed. That would be in this format. It could be sine of x over, cos of x over sine of x. One is the derivative of the other. So if you can see something like that, or you can rearrange to get it in that sort of format, then when you would integrate that, you're just going to be coming back to there. So integrating natural log functions is actually quite simple, because get it in this format here and I know that it'll work back in the same way that I worked forward. This topic in the course shouldn't take you long. If you spend more than a week at the max on differentiation integration of log functions, you've probably spent too long, okay? 3 or 4 days is probably what you need, get a good handle on it, move on. But be careful that, of course, in here, we can add in lots of different things. It could be chain rule, it could be quotient rule, it could be product rule, it could be trig. There's lots of stuff that can go in there and test 2 or 3 things at a time. Okay? So don't just see these questions in isolation. See them as a vehicle that we use to test the other simpler stuff as well. Hope this video has helped. Rewatch it again if you need to. Enjoy. See you later.